Today, we want to pick up where we left off talking about transformations of graphs. Recall that we had two operations that we were going to perform, addition and multiplication, and two times we could apply those each of those operations before the trig function or after the trig function. Addition produces a shift. Multiplication will produce a stretch or a compression. Operations before the trig function have horizontal effects. Operations after the trig function have vertical effects. So if we list the things that happen to turn x into y, so if we just read the order of operations on what happens to the x, the first thing that we do is we subtract c. This is addition and subtraction, so it's producing a shift, and it's horizontal because it's happening before sine or cosine. The second thing that happens is that we multiply by b. This is a multiplication that happens before the trig function. So if we want to classify these, since this is addition and before, it's a horizontal shift. Multiplying by b is a horizontal stretch. Then after we multiply by b, we take the cosine or sine, and now we're into the operations that happen after the function. So after we do the sine or cosine, we multiply by a, and that's going to be a vertical stretch. And then finally, we add d, which is going to be a vertical shift. Think about the basic function y equals sine of x or y equals cosine of x. The horizontal stuff, the stuff that happens before the trig function, are changes to the input before the trig function happens. Ultimately, what's going on, the key thing that's going on here is sine or cosine. That's what's defining this function. The rest are just modifications to that. So subtracting c and multiplying b by b, those are things that happen before the trig function. They're changes to the input of the function cosine or sine. After cosine or sine happens, we multiply by a and we add d. These are changes to the output of the trig function. So the horizontal shift and the horizontal stretch, those are adjustments to the x. Vertical stretch and vertical shift, those are things that are changing the y. If we think about our base function, sines and cosines. We need to know how to take these four changes and produce a graph when we're looking at an equation. So we look at a function, be able to produce the graph. We also have to be able to look at a graph and produce a function. Because in math class, when you're learning math stuff, you have to learn it backwards and forwards. So I give you an equation, you tell me what the graph looks like, or I give you a graph and you tell me what the function looks like. Now we can get into the particulars of what these four numbers mean in the graph. And I can't remember if we got to this part yesterday, so we'll just get to it today. This last one, the vertical shift, that's the easiest one. Anything that's just plus some constant at the end, that's going to tell you where the middle of the graph is. So D, the middle is at D. The coefficient A, the value of A, the absolute value of A, will tell us the amplitude. The sign plus or minus tells us something else. But we get the amplitude the coefficient A is also going to tell us about the what we're going to call the starting point. Even though these graphs go on forever in both directions, we're going to pick one point to be like our starting point. Cosine starts at the top or the bottom. Sine starts at the middle. Those are the starting points. Cosine starts at the top. So the cosine will start at the top or the bottom. The sine will start at the middle. Remember, there were two different middles, the middle going up and the middle going down. So cosine means it starts at the top or starts at the bottom. The amplitude comes from the coefficient, the absolute value of the coefficient. So the sign tells us which part. Do we start at the top or the bottom? Do we start at the middle going up or the middle going down? So if A is positive, we start at the positive one. If A is negative, we start at the negative one. So if A is positive, top for cosine, middle going up for sine. If A is negative, bottom for cosine, middle going down for sine. The horizontal stretch, this is where we get the period. The coefficient is telling us how fast we're going around the circle. So if we take 360, one full circle, and divide it by that coefficient, that'll tell us the period. So the period is equal to 360 divided by B. If we're going twice as fast, one period will be 180 instead of 360. If we're going 4 times as fast, the period will be 90 instead of 360. And then finally, we'll have the horizontal shift. This is telling us the x-coordinate of the starting point. Remember, we're just picking one to say this is the starting point. There's an infinite number of choices because the function goes on infinitely to the left and to the right. But we're going to say this is our starting point. So C is the x-coordinate of the start. Here are the 4 things that we could do to a sinusoidal function and how they adjust the function. So I refer to this starting point. the x coordinate of the starting point will just be whatever we see in the horizontal shift. If it says x minus 30, then we start when x is equal to 30. If it says x plus 60, then we start when x is negative 60. Whatever we choose to do to start, to get the y coordinate, we look at whether the function is cosine or sine, and then we look at whether the coefficient is positive or negative. If we have a cosine function, we will start at the top or the bottom. If the coefficient of cosine is positive, we'll start at the top. If the coefficient is negative, we start at the bottom. So let's do an example. Let's look at an equation and figure out what all these numbers are going to tell us. And then we can draw a picture of what's going on. Any questions before we do an example? We'd like to spread this out over 2 whole sections. Let's do this all at once. So each of these 4 numbers is telling us something. The +1 at the end, that tells us that the middle is at 1. So this +1 that's where the middle is going to be, y equals 1. Next up, we can look at the amplitude. The coefficient of the cosine is 5. So the amplitude we're just looking at the absolute value of the coefficient. The amplitude is 5. Since the middle is at 1, we can now figure out where the top and the bottom are. I didn't even put it on the line. So we know the middle is at 1 and the amplitude is 5. That's 5 above and 5 below. So if the middle is at 1 and our amplitude is 5, that means 5 above 1 will be at 6. And 5 below 1 will be at -4. We can figure out the top and the bottom based on the middle and the amplitude. Notice that I've used up both of my vertical information, both pieces of vertical information. Next, we want to start looking at horizontal stuff. If we just go one step up from on the list, we started off at the vertical shift and the vertical stretch. Now we can look at whether it's positive or negative, cosine or sine. In this one, we have negative cosine. So the negative and the cosine are start at the bottom. Cosine starts at the top or the bottom. The negative that says choose bottom. That's going to be your start. That's telling us what's going on in the horizontal shift. Next, we can look at the inside information, the before information. The 2 indicates that the period is 360 divided by 2, or 180 degrees. And finally, the 4th number that we have is the minus 15, which means the x-coordinate of our start will be at 15. Questions? Yes. Because in our base formula, we need to read it as x minus. So whatever we say after minus, that's what we're starting at. We're starting at x minus 15. So if it said x plus 15, it would be x minus a negative 15. Another way to think about it is we want to make that x minus c. What makes that 0? So if there's a minus 15 sitting there, x equals 15 makes that 0. So that's another way to think of the start. What makes the x minus c equal to 0? Any questions? If it sounded like I was prepared for that question, because I was. Because it's the question that always comes up. Yo, why is that the opposite? What the heck? But we also saw that if we think back to algebra, if we graph parabolas, in the vertex form, we say y equals a times the square of the difference between x and h. So it says x minus h squared. And then it says plus k. And the vertex was h k. The x-coordinate of the vertex is whatever we say after we say x minus. So if it says x minus 3, vertex is at 3. If it says x plus 2, vertex is at negative 2, because we'd be saying x minus a negative 2. What makes that squared thing 0? What makes this the sign of 0? So thank you for asking that question, because otherwise I have to ask it myself. And then I'm talking to myself again. And I thought, Lee, did you take your pills? And I'm like, oh, yes. Hang on a second, we know this one. Did you take the right pills? And then I start running. And they have to catch me. And it's really easy because I'm super slow. Want to find out? Here's the thing. I warned you that I was going to be late for this class most of the time because I have one that's right before and I have a lot of stuff to pack up and I have to unpack it when I get. you will never see me running from point A to point B. I was going to say on campus, but ever. I just don't do that. When I was like a younger teacher, I'd be like, oh no, I'm going to be late. And I would like run the class. But now as an older teacher, I'm like, oh, I'm going to be late. And then like, I don't do anything about it. I just observe. I'm going to be late. Then as a much older teacher, I just try to play it off. No, I wasn't late. A mathematician is never late. They always arrive precisely when they need to. But it's been too long since we've seen Lord of the Rings, so we might not recognize that. The last thing that we need to do is figure out how we're going to chop things up horizontally. We know how they chop up vertically. There's a top, a middle, and a bottom. So we're going to have a middle going up, the top, the middle going down, the bottom, and so on. We just have to pick which one we start off. And it looks like we're starting off at the bottom. Bottom, middle going up, top, middle going down, back to the beginning. But we have to figure out how to chop things up horizontally. And horizontally, everything's cut up at a quarter period. So once we figure out the period is 180, a quarter period is 180 divided by 4. So that's going to be 45. That's how we chop things up horizontally. So let's now use our information. I'm going to start at the bottom, and I'm going to label that X value as 15. So my first point is going to be here at the bottom, and we're going to label it with 15. And the Y coordinate at the bottom is -4. Next, we're going to go up to the middle, and then up to the top, then down to the middle, down to the bottom, back up to the middle, back up to the top, then run out of space. I can go backward this way too. So here's where I'm imagining is my start. I start at the bottom. I label the X coordinate 15 for my horizontal shift, and the Y coordinate is at -4. The next X coordinate, or sorry, the next point after we hit the bottom, we go to the middle going up. From the bottom to the middle going up, that's 1/4 of a period. So if I take the 15 and add the 45, we'll be at 60. And the Y coordinate, since we're at the middle, is at 1. Next will be at the top. That horizontally, that is 1/4 of a period from the previous point. So if I take 60 and add another 45, that tells me that the X coordinate of this point here at the top is going to be 105. And we had previously worked out that the Y coordinate was going to be 6. Next point is going to be the middle going down. So if I take the 105 and add another 45, we'll be at 150. So back at the middle, but headed down now. So comma 1. Then we're back at the bottom. We've gone one full cycle. So if I add a quarter of the period again, like 150 plus another 45, we'll be at 195. And we'll be back down at the bottom. Then we can go on finding points from there. If we wanted to graph the function, I didn't graph this very carefully. I'm going to make a nice, quick, and dirty way for drawing sinusoidal graphs is to draw your curves, your peaks and your valleys, and kind of point the ends at these points and then just kind of connect the dots. If I went on and found some more points, if I take the 195 and add another another 45, we'd be at 140. Sorry, 240. Back at the middle. So we'll be at another point where it's the middle going up. The x-coordinate is 240. The last time we had a point where we were at the middle going up, we were at 60. And that the distance, the horizontal distance between those 2 points is 180 because it is one period between any 2 points. The same. If we go backwards from 15, 45 degrees in the other direction, if I look at 15 and subtract 45, if I subtract a quarter period, that'll tell us what's going on here. Here we'll be at negative 30, in the middle at 1 again. So one point, the middle going down, is at negative 30. The next point where the middle is going down is one period later. Negative 30 plus 180 is 150. If I send this back to the previous point at the top, since I don't have space to write a point up here. If I take that negative 30 and subtract 45 again, now it'll tell us what's going on. That this point is at negative 75, and the top is still 6. Notice that the 2 top points, one is at negative 75, the next one is 180 degrees later at 105. Negative 75 plus 105 is a 180. Any points with the same names, all the tops are 180 apart, all the middles going down are 180 apart, all the bottom are 180 apart, all the middles going up are 180 apart. Any questions? Is everybody okay? Once we're looking at the graph, we can see all these different points. We chose to start off at the 15, negative 4 because our original function had a negative cosine. And that indicates we should start off at the bottom at our horizontal shift. But once we have all these points, notice that each one of these points is just another place we can choose as a start. So with this same graph, I could come up with an alternate description for the same graph. So what we can do is come up with more functions for the same graph. We just consider a different point that we start at. So I could say, for example, let's start at this point, 60, 1. And it's the middle going up. Let's consider 60, 1 to be our start. We'll note that it's the middle going up. Middle says we should be using sign. Up means we should use positive sign. The 60 says our horizontal shift should be 60. The amplitude and the middle are still the same. Amplitude is still 5. And our middle is still at 1. So I want to write an equation for the same graph. I'll write y equals. I'm starting at the middle going up, so I'll do a positive sign. The amplitude is still the same at 5. The period is still the same at 180, so that doesn't change my coefficient of the x. We have x minus our horizontal shift of 60. And the middle is still at 1. Here's another equation that will give us the same graph. Of course, I didn't have the right graphs programmed in. Oh, I could have used that. So let's graph our original. Our original function said y equals -5 times the cosine of 2 times x minus 15 plus 1. I'm going to artificially draw in my middle. It's been adjusted, and I'm going to make it color match. So our top is at y equals 6, and the bottom is at y equals -4. So we can see here's our 15, -4. There's 60 and 1. There's the top at 105.6. Those are the first 4 points that we plotted. Now let's change the equation to the new one that we just found, where y is equal to +5 times the sine of 2 times x minus 60 plus 1. And that graph is sitting right on top of the other graph, if it's the same graph. Any questions? Four adjustments that we're making to the graph. We're using sines and cosines as a framework to build these sinusoidal graphs. But more importantly, we've got to think about what transformations we're doing. Addition always produces a shift. Multiplication produces stretches. Is everybody okay? Take a look what happens here. Let's look at this cosine x. Let's think a little bit more about this horizontal changes and vertical changes. Something to think about before we take a break. So y equals cosine x. We know that this graph is just going to start off at the top and go up and down as x marches along. It'll be back up at the top every 360 degrees. There's 360, and there's 720. Let's take a look at what happens if instead of just changing the before to something boring like 2x using multiplication, that's just taking the whole x-axis from your perspective and making it go through twice as fast. That's why we're compressing by a factor of 2. Let's muck with this just a little bit different. Well, that escalated quickly. So here's what we did. Here's what happened. Normally we got cosine, and as x goes along, we get these nice even things because x's are coming along at a nice even pace. Even if I change it to a 2x, they're just coming along twice as fast. But look what happens. Let's move it around there. If we zoom in, we get a little bit of an idea about what's going on. What's happening is instead of the x-axis being the x-axis, where all the x's are nice and evenly spaced apart, we're taking infinity and bringing it in faster because we're going up by squares. When x is 360, x squared is 360 squared. I should have looked up 360 squared so it would look like I can make that calculation off the top of my head. But when x is 100, x squared is at 100 squared, or 10,000. Is it 10,000? Yeah, 10,000. So instead of all the stuff that cosine does between x equals 0 and x equals 10,000 happening at nice even pace, all that it gets crammed into 100 units of x. We're making infinity come faster, and that's why the graph is getting all shoved up against the x-axis, the y-axis. That's why we have this uneven compression, because we're not doing a linear compression. X is going up by x squared. If I change it to the other direction, now when we zoom out, oh, it's not changing enough. Yeah, I should have waited for I got ahead of myself. Notice that we don't hit the bottom. Yikes. Until we get to like 8,100. Normally we start off at 0 and it drops down to 8100 at 90, right? So, or start off at 1, and it drops down to 0 at 90. But now we're going through the square root. X doesn't become 90. The inputs of the cosine don't become 90 until X gets all the way out to 8100, where the square root of 8100 is 90. And so that's when we hit the bottom. So we're taking infinity and we're pushing it farther away. So we're taking the graph and we're stretching it out and making the numbers come more slowly. X squared compressed things in because infinity was coming faster. Square root of X pushes the infinity away. Any questions? Let's take a break and not think about that for 5 minutes so that we give ourselves a chance to think about it later. All right, let's take 5.